These are the 10.3 notes for Trig. We're going to talk about graphing lines and circles today, but in polar form. So for the first two problems, example 2, there we go. All right, so for example number 1, we have theta equals pi over 4. So pi over 4, if you think about it on the unit circle, is right here. So when we want to draw a line towards pi over 4, we're going to start from the center, and we're just going to draw that line towards pi over 4. So on our graph, you just kind of have to take your unit circle and see which one is the pi over 4, and then you can graph that line. So pi over 4 would be right here. I'm going to start from the center and draw my line out towards pi over 4. And then I'm just going to extend that line along the other direction. All right, example number 2, theta equals 5 pi over 3. So again, identifying where 5 pi over 3 is on your unit circle, down here. And we'll just draw a line from the center towards that direction. So 5 pi over 3, these graphs have, you can see extra lines. 5 pi over 3 would be this one right here. So on our circles, the points that we have would be here, here, and here in each section. 1, 2, and 3. 1, 2, and 3. All right, so we'll draw that towards 5 pi over 3. And then again, extend the line along the opposite direction. All right, so those are both as theta equals. Every time you have that theta equals, you're going to have a line. As we move down to examples 3 and 4, now we have r equals. R is a radius or a distance. So think about this as the radius of 3. So if your center is right here, a radius of 3, you would just go out 3 each direction. 1, 2, 3, 3, 3, and 3. So it's almost like you're going to draw a circle around that third ring out. Okay, circle with radius 3, r equals 3. And then same thing on example number 4. This one has a radius of 7, so you count all the way out to 7. Each direction. And then you just try your best to draw that circle. Okay, so those two things are pretty straightforward. Again, just drawing the line or drawing the circle. The next thing we have gets just slightly more complicated. We have r equals 4 sine of theta. So the first thing I want to do is graph this with a table. And notice how this has now an r and a theta, whereas the problems on the front had either one or the other. So when we start, we're just going to draw, see what this looks like using a table. So from our unit circle, I'm just going to, because we're talking about sine, I'm going to select all the numbers, all the values of sine around the circle that are going to be easy for me to plug in. So if I look at all the y values, I can easily plug in 0. I can plug in 1/2. I could change it to 0.5 and plug it in. I don't really want to use square root of 2 over 2. That seems too complicated. Same with square root of 3 over 2. But I'll use 1. I don't want to use radical 3 over 2 or radical 2 over 2, but I'll use 1/2. I'll use 0. We'll just kind of go that direction the whole time, using the 1/2s, but not anything with a square root. And so these are the things I'm going to plug into my table. And instead of plugging in the values, 0, 1/2, I'm going to plug in the radians. So I'm going to plug in 0, pi over 6, pi over 2, 5 pi over 6, etc. Let's put that on our circle, on our table. We've got 0, pi over 6, pi over 2, 5 pi over 6, pi, 7 pi over 6, 3 pi over 2, and 11 pi over 6. Again, these are all the ones that the value is either 0, 1, or half. So when I plug this into the equation, I will have 4 sine of 0. So 4 sine of 0 would give us 4, and the sine of 0 happens to be 0. 4 times 0 is 0. And then 4 times the sine of pi over 6. I look at my value for pi over 6, it's 1/2, so 4 times 1/2 gets me an answer of 2. I'm just going to complete this table for all of them. And you can see that this is not a short process. So on example number 6, we're going to learn a shortcut. But I at least wanted you to see where these numbers came from and how we got this shape. Sine of pi over 2 is 1. So that gets me 4. 4 times the sine of 5 pi over 6. Sine of 5 pi over 6 is 1/2. So 2. 4 times the sine of pi. Sine of pi is 0. So that gets me 0. 4 times the sine of 7 pi over 6. Let's see, check my unit circle. 7 pi over 6. The y value is negative 1/2. So that gets me negative 2. 4 times the sine of 3 pi over 2, which is 4 times negative 1, which is negative 4. And finally, 4 times the sine of 11 pi over 6. The y value at 11 pi over 6 is negative 1/2, getting me negative 2. All right, so again, long process, but we're only going to have to do this once just to see the shape, and then we'll kind of go with some shortcuts. All right, as I plot each of these points, 0, 0, that would be a dot right here in the center. That's my 0, 0. So I took care of that one. Next one, I have pi over 6, 2. Pi over 6 is going to be right here, and I just want to go out 2 in that direction. Took care of that one. Pi over 2 is up here, and I want to go 4 in that direction. 5 pi over 6 would be this one. 2 in that direction. Pi, 0, that goes actually on the same dot I just graphed. 7 pi over 6. 7 pi over 6 is down here. And this one's asking me to go negative 2. So I'm going to switch colors so you can see what happens here. So instead of walking towards 7 pi over 6, I'm going to walk away from it 2 places. That lands right there, on top of another point that I've already made. All right. 3 pi over 2 is down at the bottom. I'm going to go negative 4. Again, you can see 1, 2, 3, 4. As I walk away from it, it's going to land again on the same dot I've already made. And 11 pi over 6 is over here. And I'll walk negative 2, which away from it puts me right there. So you end up with the 4 dots happening over again. What this creates is a circle. It's just different from our other circle because it's not centered at 0, 0. It's touching 0, 0, but it's not centered there. So as we look at the shortcut now, we kind of know what shape it makes, but there's got to be a faster way to do it. So here's what I want you to notice. First of all, the 4, that's this distance right here. That's the diameter. So the first number is the diameter. So as we look at this next problem, 2 is the diameter. All right. Then notice how this circle is above. If you're thinking about the axis right here, this circle is up in the positive direction. So that's why we have the positive 4. It's also sine because it's in the y direction. So it's on the y-axis. We moved it up or down from the center. We moved it up from the center. So for this one over here, if I see a negative cosine, the cosine is going to tell me that it's going to be on my x-axis, moving either right or left. And the negative is going to tell me that it's going to move left, So let's see if we can graph this. I need always a point at 0, 0. So we'll start right there. And then I need a diameter of 2, but it has to be on the x-axis and it has to go towards the left. So left 2, and then just make a little circle. Let's try that on the next one. -5 sine. All right, so sine is going to tell me that it's y, which means it's going to be up or down. And because of the negative in front, it'll be down. It's going to have a diameter of 5. So we'll, start in the center, 0, 0. On the y-axis, you're going to go down 5, 1, 2, 3, 4, and 5. And we'll need to make a circle. Now, one thing I want to mention, Delta Math does ask you to plot the center of the circle. So anytime you're plotting the center of the circle, just do half of the diameter. So this one's actually going to be 2.5 in the middle. If you do the other one here, center of 1. Over here, center of 2. All right, example number 8, last one. 7 cosine of theta. So I know it's going to be on my x, and I know it's going to be left. Nope, right. Because it's positive. All right, and then I'm going to go from the center, out 7, and create a circle as best you can. And then half of 7 would be 3.5, so your center would be at 3.5. And there we go.